Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial demo for Chapter 3 for the class SignWriter. And in Chapter 3 of the Reggies and Step book, we're practicing working with passing parameters to methods, and we're also practicing returning values from methods as well. And SignWriter is a program that does that. So let's talk about what SignWriter does first. I'm going to show you in a text file what the effects inside of SignWriter should be. So I'm in my Chapter 3 demo project, and I just want to show you there are text editors other than the Java text editor available in Eclipse. And I'm going to create a text file in Chapter 3 demo directly inside the project. So I'm going to right click there, and I'm going to say I want a new, and then I'm going to come down and pick Untitled Text File. Okay, so that's what I have right now. And let's just put a couple of characters into it. And didn't want those in uppercase though, so they're in lowercase now. And let's say we want a file, so we can say file, save as, and where are we going to put it? We're going to put it in Chapter 3 demo. So I didn't pay attention to where I had it. And I'm just going to put it right here inside the project. I'm not going to put it in the source folder because it's not really going to be Java source code. Okay, and I'm going to call this requirements for SignWriter. Okay, so that's what we've got. Okay, and if you look over here in the Package Explorer panel, there is a file that shows up, and it looks like it's under the JRE system library, but it's really hanging under Chapter 3 demo project directly. So if we close source, we can see, and we could open the library, and we can see that's not really in the library. It kind of looks like it's hanging off of there, but it's really hanging directly off of Chapter 3 demo, which is the name of the project. Okay, so here's what I want to do. I want to, sometimes when you see people kind of doing old style computer graphics, they would want to take some kind of a title of something and turn it into a sign, like a banner kind of a sign. And maybe do it for the heading of a report or the heading of a screen, something like that. And what they would want to do is that they want to take a string of text and they would want to make it more dramatic. So let's just take a string of text here. We're going to say Java is a fun language. Okay, which either you believe or you don't. And the method that I want to create would take in a string like this that was in whatever case. In this case, it's all lowercase. And I wanted to do two things. What I want to do is I want to spread it out wider. So I want to put one space in between each of the letters, and each of the spaces that's already there I want to turn into two spaces. Okay, and I want to shift everything to uppercase. So I want this to read now as Java space space is space space a space space fun space space language. Okay. Now, you can argue whether this is dramatic or not, and you can argue, whether this is good use of typography. But of course, you could do a lot of things here to the typography. I just want to pick one particular application that's fairly good. I mean, people did this for a long time. It's a little bit old school. Okay, so the method we're going to create is going to take in a string that's in its normal state, okay? It's going to pick it apart character by character, okay? And it's going to add a space in between, add an extra space, okay? And that's going to be the same all the way through. And it's going to shift the text from whatever case it's in to uppercase. It might be in lowercase. Okay, so let's, or it could be in uppercase already, in which case it should work good, just fine. So that's what we want to do. And of course, we want it to work with any particular string. We don't want it to only work with Java as a fun language. All right. So let's go into the source folder and create our class, which is going to be called SignWriter. Okay, so sorry, it's not all in caps, SignWriter. And that's going to have a main, so we're going to check that. Okay. Okay, very good. And I've already thought of head, and I've thought of what would I call my method that does the work. The method that's going to be the little conversion tool that turns that first string that you saw on line 1 of my text document to the second string. I decided that that's going to be called format sign text. So I'm going to say public static, because that's what I do in these top level classes. Then the return type. Up until now, we've had void for the return type. Okay, this returns a value. What kind of value? Well, it's a string value. So string, it's a class name as a capital letter. Okay. Now we're going to have the name of the method, format sign text, okay? And then we are passing in a parameter. It's also a string, so string with a capital S, okay? And let's call that input value. Okay? All right. And we're going to put the curly braces around it, and we've got the whole thing. All righty. Now, let's set this thing up to be tested. Okay, so again, you have to remember that when you're returning a value, you need to use it somewhere. So let's save it in a string. So let's say string, the answer, no, string formatted text equals, and then we're going to call format sign text, and we're going to pass it a literal string, okay? And I'm going to say Java, let's put it in all over, Java is a fun language. Okay, so let's put a period there. No, let's not put a period there because it's the sign. Okay, and of course we always have to end with a semicolon. Okay, that's great. So now the answer that we want is in formatted text. Okay, that should be the capitalized and spaced version of Java is a fun language. So let's print it. And again, the quick way to get a print instruction is just to type sysout and then control space. Then we have that, and we're going to print out format sign text. Okay. No, not format sign text. What a silly goose. Formatted text. Formatted text. No more silly goose. That worked fine. Okay, just making sure you guys are awake. Okay, so this is pretty good test code. Okay, and it's calling an empty method. The plumbing of the method is correct. It returns a string value, okay, and we are acting like it returns a string because we put the call to the method on the right side of an assignment statement, and then we assigned the return value to a string variable. So that's great. And then of course we printed the value inside the string variable. Okay, but we've got problems down here, and this has to do with the fact that the compiler is relentless in keeping you from making mistakes, okay? It says this method must return a result of type string, okay? It says as soon as we stop putting void as the return type and we say string, it wants us to have a return statement that returns something. Okay, so let's return a string. Now, there is a method of testing programs that I'm going to be reviewing with you in about 4 weeks that we call test-driven development. And it turns out we do things exactly like this. What have we done? We've written the test before the code. That's interesting. So we just have a shell for the code. What's the first thing that we do? What we usually do in test-driven development is we begin by returning a wrong answer, just to prove that we can get an answer back. So what would be a wrong answer? Well, let's do this. Let's declare a string, call it answer, and let's give it a wrong value. This is definitely the wrong answer. Okay? Okay, and then what do we have to do? Well, we have to return it. So that's the thing that you're doing just when you're finished. So let's say return answer. Okay, I'm going to get some of the extra blank lines out of here. I'm usually a little bit free with the blank lines and run out of space here. Okay, so we declare a literal answer. We haven't done any work at all, and we say return answer. So what are we going to expect? Well, the first time that we test this, we're going to expect to get a wrong answer. Okay? Instead of saying Java is a fun language formatted as signed text, we're going to just say this is definitely the wrong answer. Let's do this, then we'll talk about what we've proved. Okay, so we're going to run as Java application. I guess I forgot to save it. This is definitely the wrong answer. Okay, well, it's a successful test. Okay, because we were expecting to get a wrong answer, and we got a wrong answer. That's good. What have we proved? Well, we've proved that the plumbing between the code in main and the code in format sign text works. Proved that you're able to call it and you're able to send back some kind of answer. Okay. Okay, what's the next thing that we usually do in test-driven development? Well, the next thing that we usually do is we usually force a phony correct answer. Okay? All right, what would a phony correct answer look like? Well, it would look like this. Java is a fun, language. Okay, so let's see that. Okay, now we're getting to work, but we're cheating. That's okay. Test-driven development people, which will eventually become, we like that. Okay, we like a little cheating. So let's run this test. Oh, so that's what a successful result would look like. That's great, okay? But we really haven't done the work. We've cheated, all right? But we have succeeded in proving that the plumbing works, okay? We had a forced failure. We had a forced success. Now we know that the relationship between the calling code and the called code works great. We know that we can print the result out and see enough information that we can test it by inspection, which is the way we do testing in the early part of this class. So that works great. Now we just have to find a way to put the real code inside. Okay, how do we do that? Well, first of all, we probably don't want to put anything in answer at all, but it would be good to give it a blank value so that we answer when we start is blank. Okay, that looks good. Next, what we want to do is we want to pick apart the string that's coming in, input value, and we want to look at it character by character. Well, how can we do that? Well, it turns out that the string class contains a bunch of methods that are available for every instance of a string object. And one is char at. Okay, so this gives us the opportunity to go through a string and pick the characters out individually. Okay, all right, let's look at this. So let's create a loop. So first of all, let's figure out how long our string is. Okay, so we can say we want to declare an int, lowercase, int input length equals, and you can take any string object and ask you to give it its length. So we just say input, it's on the wrong keys, input value length. There's a method, and it returns the length. So now we know how long that is. Okay. All right. So now we want to create a for loop and go all the way around. Okay. Through the entire length of the string and see if it does what we want. Okay. 4, and we're just going to use I because there's a tradition in using I, J, K, L, and M as the control variables for subscripts. It comes from the 50s in the Fortran language, and we just tend to do it now. It gives us, I said subscripts, but that's what they were called in Fortran and COBOL and PL1. In Java, these are called indexes. But we, so we still use I, J, K as the names for the control variables because there's a tradition. And they're very succinct. So we're going to say for int I equals 0, I less than input value length, okay, I plus plus. And now we're going to put curly braces on this because we're going to have some work that we do in the body of the loop. But let's just look at the values that we picked up here for the control loop because they're not as obvious as you might think. Because of the fact that the indexing of the characters within a string starts with 0, if we ask for char at index 0, we're going to get the first character in the string. It's off by 1, okay? So we're going to want, let's say we have a 10-character string, okay? We're going to want to start at 0, and the last one that we want is going to be 1 less than the length of the string. So that's why here we're not using less than or equal to, we're really using less than. Because the length hasn't been adjusted for this counting from 0, okay? So we use less than, and that works out fine. Of course, we use the plus plus. Okay, so then how do we get the, how do we get something looking like what we want to get out of here? How do we get that done? Okay, so let's do this. Okay, so first of all, we have to get a char. So let's declare a char. Okay, I'm going to call it this char equals, and then we can just ask the input value object to run its char at, and we're going to use the control variable I. Okay, so we're going to get that. And now what we're going to do is we're going to want to turn this character back into a string. Okay. How do we do that? So there's a type difference between characters and strings. Okay. So here's what we're going to do. Let's just pause for just a minute. Okay, so we're back. And what we're going to do is we're going to take this a character at a time, and we're going to build an output string that we want. So how could we do this? Well, you can mix types in Java, and sometimes Java, the language, will accommodate the conversion of types automatically. And it turns out that we can do something like this here. So this char is what we want to add to the string. And of course, what we want to do is we want to add this char to the string plus a space to come after it. Okay. So let's do that. So we're going to say, we'll do it the long way first. Okay, so let's just say answer equals answer plus this char plus a space. Okay? Now, it just turns out that Java is very forgiving. And even though we have a string variable answer and we have a string literal with the space, we are able to concatenate a char, which is really a different type, only holds a single character, and Java generates the code to turn this into a string. So what we're going to get is the character that we just pulled out of the input value string is going to be turned into a character and concatenated with what's already in answer. It's going to put the character in and it's going to add a space after. Okay? So that's going to take care of that. And let's get rid of our extra lines. Okay. Very good. Get rid of our extra lines. So we're going to run around through the whole string and we're going to put into the answer each character and we're going to follow it by a space. Now, does that work? Yeah, it creates an extra space on the end of the string. Okay? Do we care? No, not particularly. Extra spaces on the ends of things are not particularly problematic, so we're not going to worry about that right now. Perhaps what we could do would be to tidy it up after we create it. If the last character in the string is a space, we could remove it. But I don't think we really want to do that. Okay, so why don't we run this? What we should get, we haven't done anything with the uppercase yet. Okay, so when we run this, the answer that we expect to print out is Java is a fun language with this wider spacing. Well, let's see if that's going to work. Well, you can see down here that I've already tested out this approach while I had you on pause. But pay no attention to the man behind the curtain. So this probably will work. We're going to save and we're going to run. And it says Java is a fun language with the spacing that we want. Gosh, that's great. So we almost have all of the capability that we want. Okay. What we need to do is we need to turn this char into an uppercase value. Okay. And there are a couple ways to do it, but one of the things that we could do is we could turn this char into a character string, and then we could use the method that all character strings have to go to 2 uppercase. So let's do that. Okay. So how are we going to do that? Well, get a couple lines in here. So let's create another string. And let's call this char as string. Okay, all we're going to be doing is converting the type. Okay, so this character string, we're going to assign it this char. And I think that works. No, it doesn't work. Okay, so that's not going to work. So we're going to have to learn how to use a little conversion utility. Okay, so let's do this. There is a class, kind of like the math class, and it's for working with characters. Okay, So we are going to use it. It starts with the C, with character. Okay, that's the name of the class. It's a static class. Well, it's a class with all static methods. So if you character to string, and then we're going to put in parentheses this char. So this is how we convert a single character to a string. Okay? Now, these classes, this is called a wrapper class, and it does a number of things we're going to learn about as the course goes on. But one of the things it does right now is it holds methods that are handy to use with characters. And one of the handy things we want to do is to create a single character to a one character string. And that's how we do this. Okay, so we've got that. Now that we have this char as string, okay, let's do this all the long way. Okay, let's create another string. Okay, and we'll call it this string in upper, okay, equals this char as string, and then we call the method to uppercase. Okay, so that's all that's going to do is we had to turn it into a string in order to take advantage of the method to uppercase, which is not available for chars, but is available for strings. Well, have I got a surprise for you? I took another pause and I reacquainted myself with the capabilities of that character class, and we can turn characters into uppercase. So let's do this a little more directly. Apologize for the indirection, but this will give you some kind of idea about how real programmers, how much they remember about what each of the classes do. I just looked at a thing called the Java doc, which I'm going to teach you how to do soon. And I saw that there was a to uppercase for characters, which was in the back of my mind. So let's get rid of all that conversion. Okay? Okay, let's do that. So let's create another char. Okay. This char as upper equals, okay, character to upper case, and this char is the parameter. Okay, so now we've gone from a normal case character, whatever it is, it might be lower, it might be upper already, to an uppercase character. Okay, that's fine. And now, how do we get this added to the character string? Well, we already have this that adds it to the character string, but the one that we are adding is this char instead of this char as upper. So let's just change the name, this char as upper. and that should take care of it. Okay, so we just did a little more conversion using the character wrapper class, which is essentially a utility case for working with the char primitive type. Okay, let's give it a run. Save, run. Java is a fun language. Oh, hey, that did everything that we wanted it to do. Okay, and again, you might argue that's not the best signage of all time, or not the best report title of all times, but that's what we set out to do. Okay, so how about the other thing we want to do is we want to prove that we can make a number of kinds of signs that test out maybe the spacing and the capitalization. Okay, so let's see, we did Java as a fun language. Let's do another one. Ooh, didn't want to do that. Okay, so we want to copy that. We don't want to obliterate it. Okay, and then the next one, we don't have to redeclare the variable. We already have the variable formatted text, so we only declare it once. So the second time we use it, we just get rid of the type name in front of it. Okay, and instead of Java is a fun language, let's do another favorite, wet birds never fly at night, but let's capitalize the first letter of each of those and prove to ourselves that we'll get the proper answer even if we're passing in mixed case. Okay, so let's run that. And let's see what that looks like. Well, wet birds never fly at night looks like it's in that kind of signage formatting. What if we have some text included that's not letters? Is that going to be treated well? So let's say 25 space wet birds never fly 66 at night. Let's see if that comes out and we get the proper treatment for all the characters. Well, that's about what I was expecting. All right, so that looks good. And so it looks like numerals are treated okay. That's good. And then what if we start out with all uppercase text? Okay. Now we had partial uppercase text and that worked out okay. But let's do something ominous like the end is coming soon. Okay, let's see what that looks like. So we're going to save that and we're going to print that and we're going to get the end is coming soon. So pretty good stuff. So we're at the end for SignWriter. We have it coded and I think pretty effectively tested. We've done something here in this demo that is a step forward. Not only did we pass a parameter into a method when we passed input value into format sign text, but we have returned a string value from format sign text, and then we've used that in the calling code. We've saved the value, and then we've eventually printed it. With a little thought, I think you'll see that we we have we've come up with a more useful method than a method that would do the printing itself. The first couple of things we learn in programming courses is we learn how to print things, because that's easy to do. And so the first couple of methods that we learn how to create, we call them, and then they print things in the method. Well, when you're trying to convert things from one format to some other format, sometimes you want to convert them and print them. Other times you want to convert them and save them and do further operations on them. So it makes a lot more sense for a method like format sign text to return a string that's formatted and then let the calling code decide what it wants to do with the string. In the case of our testing code that we put into main, it decided to print it in each case, but it could have decided to do further processing on it. So a format sign text method that returns a string rather than returns void, nothing, and prints a string is a lot more useful than the alternative. Okay? I see one thing that got done for us that I just want to point out, okay? And that is we have a line in which we calculate the input length, okay? And then I was going to use it in this test in the for loop header, but it turns out that I used the expression that gets the length again in that header. So because of that, you'll see that input length is not really ever used. That's why it has a yellow underline. So I'm just going to take out that second line. And that makes a little more compact code. That's a little more kind of big time Java jockish kind of code style. I was trying to do it one step at a time, but now we've combined them. So I just want to run the test again and make sure we get the same output, which we do. Okay, so here we are. That's the end of the SignWriter demo, and I'm going to say bye until next time. Bye-bye.